Hello and welcome to 6.1 Discrete and Continuous Random Variables. Uh, this should be fairly brief. We got a couple examples to show you as well. Hopefully you enjoy this. Definition of a random variable is a numerical variable that describes the outcomes of some chance process. An example might be simply just calling something x, right? And saying that x is blah, right? Blah might be, let's say, we're flipping a coin, right? Let's say we're flipping a coin 5 times, right? And I just want to know what the probability of getting at least two heads. And so in this case, we can say that let x be um, getting at least two heads. Or better yet, and probably a better example would be x will be the number of heads obtained, and that we want to get greater than or equal to. Okay, so we would define x as number of heads obtained, and then write it like this, and move on from there. Uh, Probability distribution of a random variable gives its possible values and their probabilities. Now, the word distribution is no different than chapter 1, really, but just in terms of probability. Um, Distribution describes the possible values a variable could take and how often it takes those values. Period. Okay, that's probability distribution. Discrete random variables are simply random variables having probabilities assigned. Okay, couple rules that just like with other probabilities, they all must add up to 1, and the probabilities must be between 0 and 1. Uh, I know how it's worded. It wouldn't make. Why would we add something that has a zero chance to it? So that's why we're saying between 0 and 1. And if it's something that does have a probability of 1, then that's going to make our life really easy for adding up our discrete random variables. One of the things we are going to be calculating is what's called the mean of a discrete random variable, which is an average of the possible values of x, but with an important change to take into account the fact that not all outcomes may be equally likely. Okay. An example that we're going to be doing a lot of is going to be with money and gambling. Okay, and we're going to see how if you keep gambling constantly, over time you will end up losing money. Another example of this is what a lot of sports teams do now with statistics, right? This is where they really hound the stats, right? Because whether it's baseball and trying to take the probability of getting on base and calculating how many runs they can get based off of that, that's basic in the very basic form of that. It's what this is right here. You see it in soccer too, with what they are saying is expected goals, right? And calculating that. This is very similar to that, and we're going to see an example shortly. Another name for the mean of a discrete random variable is the expected value. Okay, I wrote this twice, I know, but yes, it's just another name of it. And we're going to give you the formula right now. So whenever we're talking about these problems, there's going to be value given to certain things. Like if you're gambling, you might win a certain amount of dollars, right? Or you might lose a certain amount of dollars, and the probability of that happening will go right here. And to calculate the expected value of the bet you're making or whatever would be value times its probability plus value times the probability, and you add it all up. So go ahead and pause this and copy it down. We're playing a game of roulette. Some basic rules about roulette that you may not know, and there's a lot we can do with regards to calculating probabilities with roulette. Your book does a slightly different variation of roulette. Same, well, playing roulette, but different game. The game we're playing right here in this example is called a corner bet. To make this bet, a player places his chips on the intersection of 4 squares on the roulette table. If one of these numbers comes up on the wheel and the player bet $1, the player gets his $1 back plus 8 more. Otherwise, the casino keeps the original $1 bet. If X is equal to the net gain from a single $1 corner bet. The possible outcomes are X equal to -1 or X equal to 8. Okay? And just to clarify, roulette has numbers 1 through 1 through 36, and also 0 and 00. 1 to 36 has either black or red on around it, and then 0 and 00 is green. So based off that information, I made a table right here for us. What is the player's average gain with this game? So we have a -1 value with a probability of 34 over 38. So you only win if four of the numbers occur. The others you lose. So when we calculate this, we're going to do -1 times 34 over 38 plus 8 times 4 over 38. And when you go ahead and calculate that, you can put your calculator if you like, you'll find the expected value is losing 5 cents. So every time you bet $1 on this game, you will lose on average 5 cents. So we have another scenario with insurance. Go to pause this, read this to yourself. And part A, we're going to make a table to show the probability distribution. So that table would look something like this. We have y this time instead of x, so we have y. The two events are $300 and negative 9,900. Excuse me, negative 100. Let's try it again. Negative 199,700. There we go. We did it. Cool. So why is this not 2,000? Well, if they took out a $3,000 a month policy and this unfortunate thing happens, it'll be $3,000 less than 200,000 that the insurance will have to pay. So what's the probability of these happening? So nothing happening would be 0.9998 and 0.0002. Okay. So there's our table. So let's compute the expected value of y. So we have 300 times 0.9998 plus 0.0002 times negative 199,700. Wow, that was a lot smoother this time. And what do you get when you do that? You'll get $260. Now, what does that mean for this whole problem? It means if the insurance company insures many homes, this is just one home, right? One homeowner. But they insure many homes, on average, you're going to earn the expected value of how much they'll get per month from these homeowners is $260 each. So that's how they make their money. Nice. As you can guess, with variance and standard deviation, same steps. You take each of the individual values, these, subtract from the mean, square it, and multiply by its probability, and add them all up. That would be your variance. Okay. And then to get the standard deviation is just find the square root of that. That's it. On page 354, it shows you how to use your graphing calculator for problems similar to this. Okay, I would encourage you to go there and do it yourself, and it'll tell you how to find some of these things along with a graph of each of the probabilities that could possibly happen. Continuous random variable simply takes all the values in an interval of numbers, okay? And as definition mentions density curve. We'll do some practice with this in class. It's using our distribution curve to help solve probability problems, which is pretty neat. um, and we'll be able to take that into account. I appreciate you watching, and we'll see you in class. Bye bye now.